So welcome guys, welcome to CCI Hub, and this is your day one for your CCNP studies. This is your day one for your CCNP studies. So I hope you all might have learned what is CCNA, how to provide connectivity, how data is being sharing from one network to another network. I hope you are clear with that. So today is day one, and I'll be not taking you to the advanced level for today's session, but we'll be talking about some concept and some knowledge of yours that we can relate that you are having a good understanding about your CCNA. So in your CCNA, you must have learned about OSI model, IP addressing, and your routing and all. What does router do? Routing. How does it do routing? Static, dynamic, default routing. You definitely have learned RIP, EIGRP, OSPF, but for a basic fundamental level, not an advanced concept. So that will be covering here in your CCNP so that you can be professional. You should be not newbies that, hey, routers used to provide connectivity between two different LANs. It's not like that. You should be very much clear and with professional knowledge. Then you must have covered your switching in your CCNA, where you learn about VLANs and all, Ether channel, trunk port, access port, DTP and BTP, spanning tree protocol. You must have clear all these theoretical knowledge with lab practical. So same thing here you will be learning here in your CCNP. Here in CCNP, as we all know that what you are learning, we are learning ENCODE. That is your enterprise core exam for your CCNP that everyone has to take. Plus, we have to also learn about another exam that is concentrate exam. Okay, that is NRC. So we here in your CCNP will be covering both of them. After the end of your CCNP, what you will be seeing, you can go and compare your syllabus from Cisco. Compare what all topics does we require for your NCore, what all topics you require for your NRC. You can compare that. And after comparing, one thing will be clear that all the topics are there, whatever we have got. So we'll be not going like first we'll cover ENCODE and then we'll cover NRC. We'll be not going like that pattern. We'll have a combined curriculum where you will be learning a lot of concept, including ENCODE plus NRC. Okay. So it's not like that. I repeat, it's not like that. That first we'll be covering ENCODE and then NRC. It's not like that. We'll be covering all of them in a single full-on like curriculum from basic to advanced. Okay. So what you are going, so I hope you know in your CCNP, we have other consulting exam also for data centers, for your wireless, for your software defined band. But we are here for one thing, ENCODE plus NRC. So guys, have you ever checked the syllabus? I'll recommend you to download it from Cisco website. I'll give a walkthrough. What all does it have? Okay, not this one. So basically, Cisco want you to learn about architecture. Now you know whenever you want to build a single network, you're gonna need a switch and all. So guys, here now you're gonna be professional. So you need to learn what is two-tier architecture, what is three-tier architecture, what is spine and leaf architecture. We are having multiple architecture that we can design our network on. So we'll be covering about that. You know, in a network, we want redundancy to have multiple paths so that your network should not go down if even if one device is failing. So if you're having multiple devices or multiple paths from one point to another, you can, even if one path is failed, you can still communicate from the second path. Okay, so we'll be covering about redundancy, what is redundancy and all. Then we'll be covering about, see here, SD-WAN is a good solution. SD-WAN is a top trending concept, but here we only need to learn theoretical concept, explaining only, okay? What is control plane, what is data plane, what is catalyst SD-WAN solution, limitation and its benefit. We'll be covering all of them. Then we'll be covering about SD access, that is a part of SD-WAN. What is SD access control and data plane, we'll be covering that too. But see here, it's only theoretical. They don't want you to configure and troubleshoot this particular thing. In your CCNP, definitely will be covering about your SD-WAN, but it is only like your basic and middle level of knowledge, not only not the practical. For the practical one, you have dedicated concentrate exam, or you can go with your CCIE. Okay, Then here you can see quality of service. Can anyone of you tell me what is quality of service? Basically, prioritizing data. In your network, multiple different types of data are going. So what happens in a network, congestion can happen. So at that particular time, if quality of service is defined, we can identify which data we need to send in priority. So you need to understand about QoS, that is quality of service, and it's not theoretical, but it's configurational. Okay. Then we will be learning about what is virtualization, hypervisor, virtual machine, virtual switching. That is all related to your virtualization. You can run multiple devices, you can run multiple operating system within a single operating system. Like you will be having a host operating system, and then you are having guest operating system. So here in your CCNP, we need to cover about virtualization. We'll be covering about VRF, that is more, it is also a good topic, virtual router forwarding. Basically, if I talk about Daniel, if I ask you, how many routing table are we having in a router? How many routing table can we have in a router? Daniel, can you let me know? Two, three, one, four, seven, what? So basically, we are only having a single routing table that contains the best path. But due to some specific scenario, we need multiple different routing tables. So we'll be learning about that thing in VRF. We'll be learning about some VPN concept, that is GRE and IPsec tunneling. It's related to your basically VPN, basically providing secure communication between devices. Okay. And here, all of them, LIPS, VXLAN, these are all virtualization concepts. So we'll be covering them too. So instead of going and walk through about each and every one, I'll share this PDF to you on the drive link. Please go and check out that what all topics you will get here, so that you should be like confirm that these topic we'll be covering with CCI Hub. Okay. So let's start our day one instead of wasting our time to go on the already planned your syllabus. So guys, today and in your day one, we'll be learning about your layer 2 forwarding, how data is forwarding you at layer 2, not layer 3, but layer 2. So in your CCNP, if I talk about CCNP, we are having layer 2 technologies. We'll be learning about layer 2 technologies, guys. And we'll be also covering about layer 3 technology. Okay. So here in layer 2, it's switching, and layer 3 is your routing. We all know about that. And here we are having some advanced concept where concept where you will be learning about VPNs and all, SD-WAN and all, automation and all. So here automation is not that in depth, but still you will be covering topics, how we are automating things, how we are using SMTP, how we are using syslog to monitor and generate things. We'll be learning about those things. So in your day one, we are focusing on your layer 2 forwarding. We are not going in depth about layer 2 technologies, but we'll be covering topics like fundamental, how data is forwarded at layer 2. So today, on your first day, we are not going to like have advanced level of thing, but still we'll be covering about layer 2 technologies. So my first topic for your session is how data is being forwarding at layer 2. So here in this topic, you will be covering about what is OSI model, what is TCP IP model. I'll be asking some question. I'll be asking about what is encapsulation, what is de-encapsulation, what is collision domain, what is broadcast domain, how switch perform layer 2 forwarding, and we'll be covering about what are MAC address table, what are commands related to it. We'll be covering about them. Okay. So guys, are you ready? Boyo, Daniel, Baramula, Bentelina, Tata Chandu. Guys, any one of you have in doubt? Baber. Guys, your acknowledgement is like must for me, because we are working. I'm like my training is basically like TCP. I'll be delivering some content and I want your acknowledgement. If you are not comfortable with that topic, I'll not start another topic. I'll wait for your acknowledgement. Okay. So guys, Babab, can you hear me? Babab, can you hear me? Babab, Bentelina, Baramula. Daniel, Boyo. Please, anyone of acknowledge. Yeah, Baba.
Yes.
Yes, sir, you're audible.
Baba, basically, if you're comfortable, I want you to ask about question from OSI model. Okay, it's a basic topic, but still. So, what is OSI model? Can you please tell us what is OSI model? It's
So it stand for Open System Interconnection,
okay. It stands
developed
for Please mention.
developed by ISO.
Okay,
Yes, sir.
it's
It
developed
works
by.
to transfer information from source to destination.
Okay, it's basically a networking model. So networking model tells us how computers are gonna communicate to each other when they are connected in a network. Networking model tells us how computers are gonna communicate to each other when they are connected in a network. So you all know this is your computer, this is Babov's computer. We both are connected to a network that is known as the internet now. And that's how we are having this online session. So what I'm having right now, my computer, that is PCA, is transmitting some data that is traveling from the network and reaching the Babov's end. And the Babov's computer is also receiving the data and it's delivering the data to the specific application that Babov is using for this communication. That is Zoom. So we are talking about OSI model. So what happens? Your OSI model tells your computer, hey buddy, if you are sending data, you need to send data from multiple layers. So Vaibhav, you missed the point that OSI model is a 7-layer model. It's a 7-layer model. Can you name them? Daniel, if possible, can you name the 7 layers? Layer 7, layer 6, layer 5, layer 4, layer 3, layer 2, and layer 1. Can you name them, Daniel? Layer 1 is application layer. Layer 2 is your presentation layer, guys. Just covering the topic, basic concept. Okay. These things you should be clear. Application, then presentation, then session layer, then transport layer we are having here. After that, guys, which layer we are having? We are having network layer.
Network,
Yes. Then data link layer
link, physical.
and physical. So these are the 7 layers. These are present in your computer also and my computer also that we have learned. Guys, we learn about that we are not what is networking model, how computer are going to communicate is a way or it's a procedure how your computer is gonna add additional information about the data at layer 4, layer 3, layer 2, and from layer 1 it's gonna transmit the data in the physical medium. From layer 1 it's gonna receive and it's gonna transmit the data in the physical medium. So it's a total process. Guys, we are not only having OSI networking model, we are having different types of networking model. Another popular networking model that you must have heard about, that is TCP/IP networking model. So can anyone tell me how TCP/IP networking model is, or like how many layers model? Any idea? This is OSI model, and if I compare with
I think
TCP,
it is 4 layer.
so
Balamurali, yes.
Baramulli, sorry sir. Varamulli
No,
sir
no
is saying
worries.
basically saying it's a 4-layer model. Yes. So basically we are learning about from Cisco perspective. So what Cisco is saying, it's a 4-layer model. So what happens actually, the above 3 layer in the OSI, that is your presentation, application, presentation, session layer. Now all of them are combined in a single layer that is named as application layer. So the topmost layer in the TCP/IP networking model is application layer. That is a combination of these layer 7, layer 6, layer 5 from OSI model into one layer, that is application layer in TCP/IP model. Then the transport layer here, the name is same. Whatever transport layer was doing in your OSI model, the same thing it's doing here also. Whatever network layer was doing, the same thing it is doing here in the TCP model, TCP/IP model, but the name is different. The name is internet layer, and the last 2 layer are combined to a single layer, that is, you can say, network access layer or data access layer. So this is a shorter, but it is a networking model that our computer is using. your computer and my computer are not using OSI model, but it is using TCP IP networking model. So it is your layer 4, it is your layer 3, it is your layer 2, and it is your layer 1. So basically at application layer, that is your layer 4, transport layer, layer 3, internet layer, layer 2, and network access layer, that is combination of these two layers, physical and data link layer, that is network access layer. You should be clear about that. The next thing that you should be know about what is encapsulation. The next thing you should be good with what is encapsulation. So before continuing about what is encapsulation, de-encapsulation, guys, what we all know that every layer in the OSI model, TCP/IP model has its specific operation. For example, if we talk about application layer provides services to the application running on the computer. Basically, we are having multiple protocols here, like HTTP protocol, DNS protocol, SMTP protocol. How applications gonna perform like transmission of data from which port to which port. So from which service to which service we are sending data, application layer. Then whatever data you are transmitting, the data need to be translated into network format. So presentation layer is basically translating data from your application format to network format and vice versa. Basically, if your computer is receiving data, so at your presentation layer, the data is at your network format and it's again retranslating into the application format, the original format. So presentation layer, the main task is data translating, or you can say data formatting, but it can do encryption and compression as additional task. Then, we are having session layer. Before sending data, a dedicated session should be maintained. Before sending data, a dedicated session should be established between sender and destination. So session layer is basically taking care of establishing the session, maintaining the session, and terminating the session if the data is being transmitted. So session layer is not adding something above the data, but it's doing one thing. It is establishing a session. If session is not established between sender and receiver, you cannot send data. The session layer is very important. Okay. Now at transport layer, we all know that at each layer, different protocol is working. Different set of rules are there to perform their task. Now my major task is, now we are talking about transport layer. So at transport layer, two protocols are there, TCP and UDP. Okay. So basically what we say, transport layer provide end-to-end communication. What does it provide? End-to-end communication. It also segment your data. As soon as the data is received at transport layer, the data is broken into small pieces, and then these small chunks are added additional headers. So as soon as the data is received at transport layer, the first task of transport layer is to make small chunk of the complete data, and at every chunk it's gonna add additional header, transport layer header, whether the data is gonna be sent as TCP or whether the data is gonna be sent as UDP. Okay, then if I talk about, any one of you have idea what are all information added above TCP and UDP? The main thing at TCP, or if you're sending it as UDP, what at the header side, the main thing is we are adding that is your source port and your destination port, guys. So whether you are sending data as a TCP header, whether you send it as a UDP, you need to mention these two important things: source port and destination port. Now I'm gonna ask you about what are these port? What kind of port we are talking about? These are your logical port. These are your logical port. How many logical ports are we having in a computer? Anyone have idea? How many logical ports are we having in a computer? So in total, we are having 65,536 logical port in a computer. In your computer, in my computer, we are having these logical port. Logical means you cannot see, you cannot touch, but it's a concept. And the actual range is starting from 0 and it goes up till 65,530. The actual range starts from 0 and it goes up to 65,535. The port number 0 we never assign. I hope you remember this thing. Port number 0 we never assign. It's reserved. So you can start using port number 1, 2, 3, 4, and so on. These port number are also categorized into 3 categories. these complete port are categorized into three categories. If you remember, we are having well-known port. If you remember, we are having well-known port. Then we are having some register port. And then we are having random port, guys. Then we are having random port. So we are having these three ranges: well-known, register, and random port. Uh, I hope you have. I hope you all have learned about these concepts, because here in CCNP, I'll be not focusing and I'll be not going in depth about these port. I hope you learn. I know what are these logical. If you're not having knowledge, you can ask me. Okay. So let me also write down the range. So well-known ports start from port number 1 and it goes up till 1023. Okay. So these port are well-known port. Then we are having register port. These are starting from 1024 and it goes up till 149151 and is the last range. And the random port start from 149152 till 6553. So Weber, Daniel, everyone. I hope you know you are clear with logical ports. So, by looking at the port number, you can identify to whom you are talking to, which logical service you're talking to. So whether you are sending data as your TCP with a TCP header, or whether you are sending data as your UDP header, both of the header include which is the sender's logical port and which is the destination logical. Okay. Now, when your transport layer has added the data, your network layer will add what? Let's suppose this is the data. So as soon as let's suppose this is the data. As soon as the data is received at transport layer divides the data into small chunks. This is chunk 1, this is chunk 2, dividing the single data into small chunks. And then transport layer will be adding whether TCP header above every chunk, or it can be UDP header above every chunk. I hope you are getting. So transport layer is dividing this data into small chunk and then adding additional information, whether TCP or whether UDP. Now, when your data is received at network layer, when your data is being received at your network layer, what does your network layer do? Network layer will basically receive this kind of information from your transport layer, and network layer is gonna add additional information. What kind of additional information is gonna add? Basically,
Circuit destination market.
correct. But you should be clear. Like if I talk about transport layer, guys, transport layer is having two protocol, only two protocol, TCP and UDP. And if I talk about network layer is having multiple protocol, multiple lots of protocol are there. IP protocol, with the help of IP protocol, you're gonna mention the IP addresses. We are having ICMP protocol, we are having IPsec protocol. According to whatever protocol you're using to send data, that kind of header will be added above the data. That kind of header will be added above the data according to the type of protocol you are using. So basically, IP means basically providing logical addressing. So here in network layer, the main thing we are adding, which is the senders, that means source IP address, guys, who is sending the source IP address, and we are also covering the destination IP address also. Destination IP. So network layer is basically taking care only, these are not, guys, remember, when I'll come tomorrow, basically the next session, I'll be asking you about header. Today I'm not focusing like ask you question instead of delivering some knowledge to you. But the next session we'll be having literally, please go and revise the headers. What is transport layer header? What kind of additional information we need to know? What is network layer header? What kind of additional information it is adding? You should be clear with that, because now you are gonna be professional, not only by the knowledge but by the way you think. Okay. So when you are adding additional information, whether IP header or ICMP header, you're gonna mention who is the sender IP and you're gonna mention who is the destination IP. When you have added all this information, now the data will go to the data link layer, and data link layer will add its. Now tell me, at data link layer we're gonna add two important things. One is header and other one is trailer. So in data link layer, you also add additional information, but actually we add two information. We add header and we add trailer. So basically in the header part, the main thing in the data link here we are adding, who is the source MAC address. See, we are adding the MAC address information while we are sending also, not only logical, but also physical address. So we're going to mention destination MAC address also. So at the data link layer header, the main thing you are adding, that is the sender MAC address and the destination MAC address. And so Sumit, why do we require trailer field then? So basically in the trailer field of your data link layer, we are having a field that is known as FCS, frame check sequence. And basically it is for your, it is for your error checking, whether to identify there's error at data link layer or not. And from your physical layer, you are transmitting it. And from your physical layer, you guys are transmitting and receiving data. Basically, your physical layer is concerned. How you are connected in a network. Are you connected through a wired cable? Okay, if you're connected in a network through wired cable, which kind of cable you are connected? Is it copper cable or is it fiber cable? If you're connected to through copper cable, then the same data will be transmitted in electrical pulse. Whatever data you want to send, it will be transmitted as a electrical pulse. But if you are connected to through fiber cable, the same data will be transmitted in the form of light pulse. So basically, physical layer is concerned how you are connected through wired or through wirelessly, because from the physical layer it's gonna send and it's also gonna receive data from the network. So if you are connected through wirelessly, the data will be transmitted into your radio frequency, guys. Radio frequency. It will be transmitted as radio frequency. So this is one thing you need to know. Then just go and revise. Okay. Here we also have mentioned OSI model and TCAP model. Okay. Then one thing you should be clear, when is encapsulation happening and when is de-encapsulation happening? Tata Chanduji, can you please let me know when is encapsulation happening and when is de-encapsulation happening? Anyone of you? What is encapsulation? What is de-encapsulation? Vaibhav, Daniel, Bala Murlai, sir.
From sender, it will be encapsulated. At the receiving it, it will be de-encapsulated.
So as he is saying, if you are sending data, as we can see, if you are transmitting data, if sender is sending data, if any device is sending data, it's gonna process the data from layer 7 till layer 1. But the data will be processed by every layer. So as we all know, from layer 4, we are adding additional information. We are adding additional information. Okay. So that kind of process is known as encapsulation. When your computer is sending data, the data is processed from layer 7 towards layer 1 and additional information is added. So that full process is known as encapsulation, adding of additional information above the data encapsulation. And when you are receiving the data, so it's going to receive from your layer 1 and it's going to be going through till layer 7, and from layer 7 it's going to reach your application, whichever application you are using to receive the data. So what is happening at receiver end? De-encapsulation happening. De-encapsulation. So basically every layer 2 of receiver is gonna check the layer 2 information added by the sender. Layer 3 of the receiver is gonna check the additional information added by layer 3 of the sender. Layer 4, that is transport layer, it's gonna check the additional information added by the sender's transport layer. Every layer is gonna check their own layer information, not any other. Okay, so at that time de-encapsulation is happening. Okay, you are good to go with that also. If I ask you about PDUs, guys, if I ask you about PDUs, can you tell me the PDU of all of them? What are PDU? What are PDU? Protocol data unit. Yeah. So can you please name them? What is the PDU of application layer?
Data.
Data. What is the PDU of presentation layer? That is also data. And what is the PDU of your decision layer? That is
Data.
also. But what happens with presentation? As we all know, as soon as data is received at your transport layer,
Segment.
as soon as the data is received at transport layer, additional information is adding from your additional information gets started adding above the data. So see, this is your data that you receive from session layer. It's divided into small chunk, and transport layer has added successfully the data. So now what happens, guys? This complete data and additional information is now known as segment. Okay. Then when the segment goes to the next layer, then the segment. So the PDU for your transport layer, you correctly mentioned, that is known as segment. So now this segment goes to your network layer. You know, that is data with the transport layer information. Now network layer is gonna adding its own additional information. So the complete thing is having a name that is known as
Packet.
so the network layer PDU is packet. Now, when the network layer packet, whatever you have formed at network layer, that is known as packet, then this information goes to your data link layer. Data link layer added header and trailer, as we discussed about, right? It will add header and trailer. So this complete thing now will be in a different form. The data will be there, but with additional information. So what we consider this? So at data link layer, we are forming three. Nice. The PDUs are this. And what about the physical layer, guys? The PDU is
Bits and bytes.
bits and bytes. Your data is transmitted in the format of bits and bytes. Correct. So you are good to go with that also. Okay, so we have covered PDU. Now basically I hope you know about this thing. So let me draw a basic topology in front of you. Let's see how communication is happening. I'm not involving any switches here, but you can see here we can have switches also. Okay, so let's do that. Wait, let's have a switch over here so that it will make a little bit more. So here we are having multiple networks connected to each other. So see basically what happens. So PCA want to send our data to PCB. We are having multiple networks that are connected to each other. Not only we have physically connected, but we also have logically assigned IP addresses also. Okay. So what is happening? Let me go here. So PCA want to send a data to PCB. This is the data, guys. Okay. So when according to OSI model, let's see how things are happening. So PCA will send this data. He will add who is sending the source IP. He will add of himself. Above the data, he need to mention source IP address, destination IP address, source MAC address, destination MAC address. Okay. So when you can see that the destination is a different network, your data will go out from your physical layer and will be received by your router. Because you will send that same data. When your computer checks, the destination is a different device that is not within my network. So basically, he'll do what? He'll send the data to the default gateway. The source IP will be of him, let's suppose, who is the original sender. The destination IP will be of the original destination. Source MAC address will be of PCA, and the destination, because the destination IP does not belong to its network, so he knows that the data needs to send to the router. So basically, he will add the destination MAC address of R1's default gateway. Okay, R1's interface, that is the default gateway for this complete network. That's how your data is received at this particular interface. As we all know, your routers and your switches are a specific layer device. So your router is a layer 3 device. So it receives data from layer 1. It checks the layer 2, who is sending. Okay, PCA is sending. To whom is sending? Destination MAC address of routers R1's default. So he know that data is for him. So he will remove the header and trailer, and now he will check the layer 3 information. That is your routing. That is who is sending and to whom we are sending. It will look the routing table. If he is having route, then he will send out the data from the port to the next device on the path. So next device on the path, that is R2. So when R1 is sending the same data towards R2, what he's gonna add is this is the data. He's not going to change the source IP, that will be of PCA. He's not going to change the destination IP, that's going to be of PCB. He's going to change. Now who is sending the source MAC address? Now R1 is sending. So R1's, let's suppose this is gig 0/0. So R1 gig 0/0 now, and here when he's sending data out to the next device in the path, we will write the MAC address of the interface. Let's suppose gig 0/1. This is the MAC address of this interface from which he's sending, and to whom he's sending, he will add the gig 0. He will add the MAC address of the next router in the path. That is what it's actually doing, sending data from one port to another to the next router in the path. So what we can see, yes, router is a layer 3 device. It can read from layer 1, it can check layer 2 information, and according to layer 3 information, it's doing the forwarding decisions. So basically, by looking at the layer 3 information, it will check the routing table. If he's having route, then only he can send data. Otherwise, the data will be dropped over here. Okay. So what today's session is, not your layer 3 routing, but I'm just going an overview. My today's focus is on this particular part. How data is shared within a same network. That means using layer 2 technology. What all things are involved. Okay. What is collision domain? What is broadcast domain? We're going to cover all those things. And that's how the data will be received from your layer 2. Layer 2 will receive data, the same data that PCA want to send. Data source IP of PCA, destination IP of PCB. So when he's sending data to, when R2 is sending data out from the destination towards the destination, he will add its own MAC address, and the sender and the destination MAC address will be of PCB according to this topology. So what you can see, when we are transmitting data from one network to another, the data is not changed, the source IP is not changed, the destination IP is not changed. But who is the sender and who is now the next destination is gonna change over the period of time. Like whatever devices are coming, the source MAC address and destination MAC address is gonna change. So that is what we are learning here. So before learning about my main focus is to talk about layer 2 forwarding. That means how data is forwarded by switches and all. So first of all, before continuing about that, I want to know about, are you clear with collision domain and broadcast domain? These are the two important concepts that you must be clear. It's a basic fundamental thing, but you should be clear. If I ask you guys, what is collision domain? Can anyone tell me what is collision domain and what is broadcast domain? Any one of you? So basically, let's talk about. So guys, remember one thing. Before network, don't imagine today's network. Let's go back. Let's go way back in the starting point. So guys, what was happening at that time? We were having a single cable, and from that single cable, we were attaching all the computers here. Okay. So with a single cable here, we were adding some connectors that were known as BNC connectors. BNC connectors. Here we need to add BNC, because what we are doing, we are cutting this cable and adding towards the end host. So basically, we are having multiple devices, but we were not connecting through switches. We were connecting them through a single cable. So what was happening at that time? If one device is sending data, other should wait. And that data is transmitted. Let's suppose PCA wants to send data to PCD. But here in that type of, when we were not having switches, not routers, so we were connecting these devices to a single cable. So what was happening? Whatever PCA was sending was delivered to PCB, PCC, and PCD also. You want to send data to PCA, want to send data to PCD, but because of this kind of connection, the data was delivered to all of them. And there was another problem. If multiple devices at the same time, let's suppose if now at this particular moment, PCA is sending data to PCD. So it's going to be delivered to everyone because of the way of architecture, because of the architecture. Now let's suppose PCA is also sending data, and at the same moment, PCB want to send data to PCC. At the same time, PCB want to send data to PCC at the same time. So what is the result? When PCB is sending, and PC8 is also there. The data will flow to everyone, but collisions are gonna happen here. So guys, this is a single collision domain. Collision domain is domain where if multiple devices try to send data at the same time, collisions is gonna happen. Collision. So see, this is a problem that time. And what happened, guys? The same problems occurs with hub also. So you can see we are having multiple computers, but all of them are connecting to a single cable. So it's a single collision domain. So guys, a collision domain is a domain where collisions can happen. Okay. Now, if I talk about you all have learned about hub also, na? Hub is also a networking device that is used to provide connectivity between different. So instead of having all these devices connecting to a single cable, we made a device that is known as hub. In hub also, we were having some problems. What kind of problem? You can see we are having three different port, but still a single collision domain. All the ports of hub by default belongs to a single collision, even if there are three different ports. But in the logical part, it's having a single collision domain. It's just similar to this one. It's just similar to this topology. But instead of a single cable, we are having a hub over here. Another problem was this this network also supports half duplex, and here all the ports of your hub supports half duplex. So if I ask you how many collision domain are there when if you're having a hub and three different port or maybe 5, 6 port are connected, a single collision domain. Even if there are multiple port, but hub do not have a different collision domain for every port. It is having a single collision domain for all of its port, and it operates in half duplex mode. So that's why collisions were happening. Guys, if you remember, at that time, before making switch, we developed a concept that is known as CSMA/CD. Do you remember this concept? Anyone of you? Carrier sensing multiple access / collision detection. So we were using these concepts CSMA/CD to avoid collisions, but still we were having collision in the network. So what does CSMA/CD tells? Before transmitting data, check your link, whether the link is occupied or not. If someone else is sending, then you must have sense over here at this particular link that the network is occupied. If no one is sending at that time, you are allowed to send data. But the problem was what? If two devices at the same time checks whether they are communicating or not, if no one is sending, they both will try to send data, and what will happen? Collisions will happen. So even if you develop this beautiful method CSMA/CD, still collisions were happening. Okay. And what is the broadcast domain? Let's suppose it's an area and we are having multiple devices within that area. You see, a broadcast domain is a domain. If one of the device within that area sends a broadcast traffic, that broadcast traffic will be delivered to all the devices within that broadcast domain. So a broadcast domain is a broadcast area where all the devices within that broadcast domain is gonna receive the broadcast traffic. So if we talk about your hub, so hub was having a single collision domain, and all the ports of hub belongs to a single broadcast domain. That means all the port of hub are connecting to a single network, to a single broadcast domain. So guys, if so see here, I'm gonna build a topology in front of you. You're gonna tell me how many broadcast domain and how many collision domains are we having. It's a fundamental thing. I hope you guys will be able to answer it. By looking at the image, by looking at the diagram, are you sure which kind of device it is? I'm representing a hub. Okay. So guys, tell me how many broadcast domain are there according to this topology? And how many collision domain are there? Guys, I want input from every one of you. How many collision domain are there here? And how many broadcast and how many broadcast domain are there? This particular diagram means we are using hub. This particular diagram means we are using hub. This particular diagram means we are using hub. I'm waiting for your acknowledgement, guys. I want your answers. Daniel, Babar. Guys, please, if any one of you responds, it will be a like, yeah, two collision domain. Baba was saying two collision domain. Nobody. Even if you type here also, na, it's gonna good. Okay, sir. Okay, same communication medium. Okay, two collision domain. So Baba was saying two collision domain. No, Baba, no. As I mentioned, all the ports of hub belongs to a single collision domain. Even if you are connecting the devices, you are just it's a single collision domain. If PCA and PCC try to send data at the same time, what's gonna happen? Collision is gonna see here. Why collision? Let me tell you one reason. So first of all, the right answer is we are only having a single collision domain. Even if you are having three hubs, but still a single collision domain are there. And if I talk about broadcast domain, so here all the switches are connecting to all the hub are connected to each other also. So still a single broadcast domain is there. Even if you can see three switches, three hub all. So how many broadcast domain? A single broadcast domain and a single collision domain is here. Now, what is the problem with hub? So guys, the problem with the hub was it is not having a buffer memory. It is not having a buffer space. So see, if PCA is sending data at the same time and if PCB is sending data at the same time, what it's gonna do? Receive the data from one port and send out data out, send out the same data from all the port. It's not having a buffer space, but switches were having a buffer space. So that's why collisions are not there. So see, even if both the devices send data at the same time, because there is no buffer memory to hold one of them messages, the data is gonna broadcast from all the port. So PCB data is gonna broadcast and PCA data is gonna also broadcast at the same time because there was no buffer memory. So that is a problem. If I go on the PDF, let me go and talk about. So let's see. A collision domain is a network segment where if simultaneously data is transmitted, it can get collided with one another. So this particular technology, shared medium base 10 base to 10 base E, actually it's this particular technology where you are having this one, where you are having a single cable. With the single cable, you are connecting all your end hosts, no switches, no hub, nothing. But instead, we are having a 10 base 2 cable and we are having some connectors through which we are adding our PCs to this particular same wire. Okay, so every device so we were talking about hubs and collision domain. So you can see hub is a precursor of switch. We know it was invented before switch. It is you can talk like that. It's act as a multi-pole repeater. It's doing what? It's receiving data from one port and just delivering data from all the other port. Basically repeating the same data from all the other port. Hub is not layer 2 aware. It's a layer 1 device. If someone talk you about hub, it's a layer 1 device. Okay, and it cannot read your MAC address or any other thing. It cannot buffer traffic. This is the main issue. It cannot buffer the traffic. So what does buffer mean? Let me just make a connection here. So PCA and PCB want to send data sent at the same time. So this is the problem. Because the data is received from two different ports at the same time, it's not having a buffer traffic memory. So if it's gonna have a buffer traffic, so see the PC one of them will hold until the like suppose PCA is sending data and PCB is also sending data at the same time. So one of them should wait in buffer memory until the PCA let's suppose PCB was kept in buffer memory, and at that time PCA data whatever you want to transmit, it's transmitted. Now the data that was buffered in your hub or PCB it's gonna send out from all the port. It was not having that buffer memory. So a signal received on one port is repeated out from every other port immediately. If PCA and PCB send data at the same time, it will be repeated out from all the other port immediately as soon as they are received. It was not having any buffer space. So if two devices transmitted data at the same time, collision were happening. We were using techniques like CSMA CD, carrier sensing, multiple access with collision detection, and your hub was operating in half duplex mode. So that's why all the devices connected to a hub, all the devices connected to a hub share a single collision domain. That's why when I draw this topology, I was having multiple hubs in my network, multiple computers connected to this hub, but still we are having a single collision domain. Even if one of them sends data, the data will get, even if multiple devices send data at the same time, the data will get collide. That is 100% sure. And how many broadcast domain are we having here? A single broadcast domain. If PCA sends a broadcast traffic, that broadcast traffic will be received from the hub. It will transmit the same traffic from all the other port. It is received by other hubs. It will also broadcast to all the other devices in the network. So it is creating a single broadcast domain also. So now let's go and talk about your switch, because today we are just focusing on your layer 2 forwarding, only layer 2 forwarding, not anything more, anything less. How data is transmitted at layer 2. So you should be clear what is collision domain, what is broadcast domain. Even if you are having multiple ports and hub, but still we were having a single collision domain. So now we are talking about switch. That is a smart device because it's layer 2. It can check layer 2 information that is present above the data. And you know what is layer 2? Data link layer. Source MAC address and destination MAC address. That means to forward the data toward the destination, it can check layer 2 information. To send data from to the destination, it can only read and check layer 2 information. Okay, let's see what else we are having. So here again, how many collision domain and broadcast domain are there? So let's just go and read out things from here. So switches are layer 2 away. They can read destination MAC address from the header and decide which port to forward the data out of. Because switches were having not only layer 2 away, they were having a MAC address table also. Within that MAC address table, it's storing information about which MAC address is connected to which port. According to that information only is forwarding the data. Switches can buffer frame. That means if switch receives multiple data, if a switch receives multiple data, let me draw it here. So in networking diagram, switch is gonna represent in this particular manner a rectangular box and 4 arrow in the same pattern that I draw. So see, what is the best part? Why switches don't have collisions? So basically, PCA want to send data at the same time to someone, and PCB also want to send data to someone else, but at the same time. So what was happening? Switches have capability to buffer frame. So it will choose one of them. Like let's suppose it will make PCB hold in buffer memory. Till at that time PCA data will be transmitted, and after that millisecond, it's a millisecond work. Okay, after that millisecond, then whatever the other frame was kept in buffer memory was released, and then it will be transmitted. So it has it has that buffer power that your hub was not having. So as soon as your data was received from any of the port, hub was immediately transmitting. But switches can hold that data in the buffer memory. Even if it receives multiple data at the same time from different port, it will only allow one data to be transmitted across the network, and other data will be kept in buffer only for a few seconds, only for very microseconds, nanoseconds basically. Okay, so remember that point. Switches have a space to buffer the frames. Every switch, now this point is very important. Every port of your switch has its own separate collision domain. Every port of your switch has its own separate collision domain. It's not like hub. Hub was having 7 ports, let's suppose, but all the 7 ports belong to a single collision domain, but not with the switch. If I draw here, Can you tell me how many collision domain are there? This is one collision domain, this is another collision domain, and this is another collision domain. 3 collision domain you can see in front of you. The switch might have multiple port, but these port are not using. But as soon as they connect this port to another device, then it's another collision domain. So every port of your switch has its own collision domain. Every port of your switch has its own collision domain. So according to this topology, you can see we are having multiple ports, but only 4 ports are using. So this means in this topology, 4 active collision domain are there. And again, as the same purpose for switches is also there. Like hub was used to provide connectivity within a same network, within a same broadcast domain, within a same LAN. The same purpose is of your switch also. All the port of your switches are used to provide connectivity within a single network, within a single broadcast domain. So even if you're having multiple port, how many broadcast domain you're having in your switch? A single broadcast domain. You can expand your broadcast domain by connecting your switches to each other. Now that broadcast domain will be expanded. So if PCA sends a broadcast traffic, it will be sent out from all the port. Even if you're having multiple switches, that broadcast traffic will go from one switch to another, and it will be spread across all your complete network. So how many broadcast domain? A single broadcast domain. If someone asks you how many collision domain, 1, 2, 3, 4, 5, 6 collision domains are there and a single broadcast domain. I hope you should be good to go with your collision domain and broadcast domain. What is a collision domain? A network segment where if 2 devices try to send it at the same time, collisions can happen. And what is a broadcast domain? It's a domain, it's an area. If one of the device within that domain sends a broadcast traffic, all the other devices within that broadcast domain, it's gonna receive that broadcast traffic. Basically, you can consider your broadcast domain as a single network, as a LAN. Basically, you can consider your broadcast domain as a network, as a single network. Okay, so now before proceeding, I'll be drawing some topology in front of you. You just help me know, uh, get how many broadcast domain are there and how many collisions domain are there. Guys, tell me according to this topology, how many broadcast domain are there? Tell me. Even if you type your, I'm just waiting for your reply, everyone. 6 collision domain is same. 1, 2,
And
3, 4, 5, 6.
6. And 1 collision domain. And 1 broadcast domain.
One broadcast domain, 6 collision domain. So your answer is a little bit wrong. Little bit wrong. Okay. So single broadcast domain and so my answer was how many broadcast domain are there? So the answer, so whosoever said a single broadcast domain, it's correct.
6.
Broadcast domain. I was asking what the first question was, broadcast domain. So what does it mean? All the ports of your switch are member of a single broadcast domain. This port, this port, this port is member of a single broadcast domain. And when you are connecting your switch to another switch, you are just expanding your broadcast domain. You are just expanding your broadcast. And here you can see we are having a hub. So here with the hub, all the ports of hub belongs to a single broadcast domain. You see, if PCA sends a broadcast traffic, it will be received by switch 1. Switch 1 will broadcast out from all other port. Then your switch 2 will receive that broadcast traffic. It will again forward the traffic from all the other port. Same your hub will do. It will receive the broadcast traffic. It will forward that broadcast traffic out from all the other port. Okay. So this is what a single broadcast domain represents. It's a single broadcast domain. And if I talk about collision domain, at that time I got a wrong answer from your side, guys. So let me point down how many collision domain are there. Just see. Because we know every port of switch has its own collision domain. 2, 3, and 4. Okay. But what I can see here, we are having a hub over here. We are having a hub over here. So these are two different ports. These are two different ports, but still, remember, all the ports of your hub belongs to a single collision domain. Single collision domain. So here in this topology, we are having 5 collision domain. Is it fine? Just be ready with that. So here you're having a hub. So you can see two different ports, but you know the functioning of your hub. All the ports of your hub belongs to a single collision domain. Whereas all the ports of your switch have their own collision domain. Okay. Let me just go and that was the idea of your. Let me just go and make another topology. I want to get the clarity that you should be able to know what is a single collision domain, what is your broadcast domain. Guys, before giving me the answer, just check the device. You can, by looking at the device, you can see. Now tell me, how many collision domain are we having? How
One
many?
collision domain, all your hubs.
Because you're right this time. A single collision domain, because you can connect multiple device hubs to each other, but still all the port of hub belongs to a single. So these are four different hub, but all of them will be a single collision domain. Okay, let me go and add more devices over here. And a single broadcast domain also now. Now tell me how many collision domain are there. Now tell me how many collision domain are there. One single collision domain. This port of your hub, this port, this port, this port, this port, this port, this port, this port. All of them belongs to are connecting to each other, and these are hub. So a single collision domain. But here between switch and switch over here, it will be another collision domain. So here in this topology, what I can see, we are having two collision. Sorry, my internet is, I don't know what is happening over here. My internet is not working very much properly. Sorry for today's session, guys. Next time, I'll make sure that it's not the same thing. I'll try my best. I cannot commit.
You should not tell like this, right? Being a network engineer.
Still, because right now I'm here, I cannot go and troubleshoot why it's happening.
Sumit, you should not tell like this. Being a network engineer, you should know what is happening in the internet. Your
I know,
network.
I know that, but here I can't go. I have to go and look after your session. Why it's happening from morning? It's not from my end. It's basically from the ISP end. I have done the payment and all.
Yeah.
I cannot control the other
So,
network. I can.
so now you are coming into little bit technical, right? So it's from my vendor ESPN.
True, true, true,
Good,
true.
good.
So basically, we are learning about that thing only. Okay. So this is what we are learning. The basic thing, what is collision domain, what is broadcast domain, that should be clear to you. Then only fundamental should be clear to you. That's all. Now you know what is a broadcast domain. We know about that. A broadcast domain is a logical division. It's a part of a network in which all the nodes can reach to other using layer 2 broadcast message. Basically, it's what? A domain where all the devices within that domain can receive a broadcast message. A group of devices that will receive a broadcast frame sent by any one of them. Okay. So see all the devices connected to a switch.
I think I can understand it clearly. Theoretically, I can understand it, but when it comes to the diagram and all, no,
Mhm.
it gives a small confusion.
No
It's
worries.
something like when people teach, no, they teach 2 plus 2 equal to 4. But when they ask question, no, they'll ask 162 plus 225, how much? Like that it is.
Got it. So right
It's
now I'm
small confusion.
no worries, no worries.
Hello, mister.
I'll try to make it a little bit more like practical demonstration for you, but in practice for this particular session. Okay. So see here. Let me go and present a broadcast domain. Let's suppose I'm having 4 computers within my network. I'm providing connectivity with my switch because in your network you can have a single switch, you can have multiple switch. So see what I'm let me just try to make you understand by a single switch first of all. So see, a switch is used to provide connectivity between different LAN. Let me go and quickly provide connectivity. All the ports of your switch belongs to a single broadcast domain. Remember my point. All the ports of your switch belongs to a single broadcast domain, a single network, basically. So let's go and provide IP addresses, logical addresses. Let's suppose we are having 10.00/24's network. We need to assign IP address to each and every one of them. I'll go to desktop, I'll go to IP config, I'll go here 10.0.0.1 subnet mask 255.255.255.0. Default gateway we should mention because we're talking about a single network. Then we go here, we go to PC2, 10.0.0.2 subnet mask 255.255.255.0. Then I'm PC3. I'm quickly assigning IP address. That's it. So basically, we are trying to understand in the form of switch. How can you say, Sumit, that all the ports of your switch belongs to a single broadcast domain? So see here, if let's suppose from PC1, I'll try to send a broadcast traffic. I'll try to send a broadcast traffic. Ping 10.0.0.255. The last IP address from this network will be the broadcast IP address. You can see that I'm getting reply from all the devices within my network. But if I show you here, if I show you by your simulation mode, now see what is happening. As soon as you try to ping your broadcast IP address, what's going to happen? Your data will be transmitted from your physical port of your PC towards the physical port of your switch. Let me show you the name over here. What's the physical port name? Preference and always show port ID. Okay. So now you can see from switch F0/2, he has received a broadcast traffic. If I open this broadcast traffic over here, you can see the source IP address will be of PCA, the destination IP address will be of the broadcast IP address, the source MAC address will be of PCA, and the destination MAC address will be of broadcast MAC address. That is 12 times F, and it's a universal broadcast MAC address. So what does my switch do? As soon as the switch receives a broadcast traffic, so it checks, I am receiving that broadcast traffic from F0/2. And he knows that all the other port belongs to the same broadcast domain that F0/2 belongs to. So what he will do, he will broadcast out the data from all the other port in the same broadcast domain where F0/2 belongs to. So right now I'm having a single broadcast domain over here, but I hope if you remember about VLANs in the network. So what we were actually doing, we were actually dividing the single broadcast domain into multiple broadcast domain by using the concept of VLAN. But right now I'm only having a single VLAN, that is VLAN. And F0/2, F0/1, 3, 4, all of them belongs to your VLAN, a single broadcast domain. You see what happens? It is receiving data from F0/2 and it will broadcast the data out from all the other port on that broadcast domain where F0/2 belongs to. Because right now we are having a single broadcast domain. So you can see that broadcast traffic is sent out from all the other. So that means how many broadcast domain we are having? A single. By default, I'm talking. Okay. So see here, if I go and increase, right now I'm having a single switch. But what I'll do, I'll go and add few more switches to make you see that it will still, even if you are adding more switches in a network, it will still be a single broadcast domain. You see, I'm adding only 3 switches, but all of them are for my network only. Let's suppose these two I'm connecting with this switch 3. Then and here. So by by providing connectivity between switch to switch, you are just expanding your broadcast domain. You are just scaling your broadcast domain by providing. So now, even if you can see 3 switches are there, but by default, all the switches belongs to all the ports of a switch. All the ports of a switch belongs to a single broadcast domain. You see what happens? To show you broadcast domain, let me go and send the broadcast traffic again. So without simulation mode, if I show you, the output will be same. I'll be getting ping reply from all the devices, 3, 4, which I was receiving earlier also. Okay. Now what I'll do, I'll just go in my simulation mode. I'll go and type ping and I'll show you. The source IP is of him, destination IP is of your broadcast IP address, source MAC address is of him, and destination MAC address is of broadcast. So for your layer 2 forwarding, those guys, for your layer 2 forwarding, your switches are gonna only check your layer 2 information, not your layer 3. So if I show you here in this ICMP again, source IP is of him, destination IP is of broadcast IP address, source MAC address is of him, and destination MAC address is of your broadcast MAC address. So as soon as your switch receives a broadcast traffic from one of its port, it's gonna check, oh, let me check this F0/1 belongs to which broadcast domain. So by default, all the ports of the switch belongs to a single broadcast domain. So it will spread the broadcast out from all the other ports. Now that same broadcast traffic is received by switch 3 and switch 2 also. So what they'll do, independently they will check. I received the broadcast traffic from my F0/3. Let's suppose I'm talking about this switch 5. Okay, this switch 5. So what this switch 5 is thinking, I receive a broadcast traffic from F0/3. So what I'll do, let me check this F0/3 belongs to which broadcast domain. So all the ports of this particular switch belongs to a single broadcast domain. So it will spread that broadcast traffic out from all the other port that F0/3 belongs to. Can you see that? Same thing happens with this switch also. This switch 4 happen, same thing. It receives the broadcast traffic from F0/3. So first of all, it will check that this F0/3 belongs to which broadcast domain. So by default, all the ports of your switch belongs to a single broadcast domain. So he will also like forward the broadcast traffic from all the other port except from the port where he receives that broadcast traffic. So you can see that broadcast traffic is spread across all the device, all my network. So even if you're having multiple devices, still even if you're having multiple switches in a network, but by default, with the by default condition, they will be creating a single broadcast domain. So that is what I'm actually trying to convince you. And if I talk about collision domain, guys, if I talk about collision domain, so every port of your switch has its own collision domain. So if someone asks me, Sumit, how many collision domain are we having here? So between PC and this switch one, a single collision domain. Between switch and switch, both of the switches are connecting to each other. So actually they are having a single collision domain over here. Okay, this is another collision domain, third one, fourth one collision domain, fifth collision domain, sixth collision domain, and this is the seventh collision domain. So according to this topology, according to the switch functionality, you know we are having a single broadcast domain and 7 collision domain. Actually, a router is also a device that is connecting multiple broadcast domains. So see, if I go here and add a router over here, just for your little bit more reference, if I go and add a router, networking devices, I'll go and add a router, I'll provide connectivity over here. And then some PCs to provide connectivity. Yeah. Let me go. So now you know, Sumit, you have added one router over here. So basically, one of the router from one of your switch, you're gonna add connectivity towards your router, and other port of your router you're gonna connect to a different network. So this router is providing connectivity between two different networks. So if right now, according to the situation, if I ask you how many broadcast domain are there, let me highlight them. So this is a single broadcast domain, and on the right hand side, it's a different broadcast domain. Okay, so 2 broadcast domain you can see in front of you. But if someone asks you how many collision domain, so earlier we were having 7 over here, then 8th one is this one. 8 collision domain, 9th collision domain, 10th and 11th. So 11 collision domain and 2 broadcast domain. Every port of your router connects to a different network, connects to a different broadcast domain, connects to a different network, connects to a different broadcast domain. Here on the right hand side, you can see we are having a switch, but here it's a different broadcast domain. It's a different network. So different broadcast domain over here and a different broadcast domain. So the broadcast that is happening over here will be only received by all the devices within this broadcast. It will be never forwarded out from the router towards the next broadcast domain. So the broadcast traffic stays within your domain only. It is never transmitted out to other network. Otherwise, if I'm broadcasting in my network, that if router are passing your broadcast traffic, then if even if I broadcast in my network, that broadcast will reach to you also. If you and me are connected through somehow in a network, that is not good thing. So broadcast domain, I hope it's clear. So is it a little bit clear or still doubt?
Yeah, it is clear. But only that collision domain when it comes to the diagram. Broadcast,
Other
I think it's very, very clear. Yeah.
very clear.
Yeah, I
Now
think nowadays we are not using hub, right? Those are
nowadays
old.
we are not using hub, but sir, we are learning
Yeah.
CCNP. For your
Yeah,
CCNP
correct.
purpose, even if we are not using hub now, still you should be clear what is collision domain. A collision. So basically, if let me just try one more time to explain. So you can only think like that. So earlier, what we were having a single cable, and through that single cable, we were connecting your computers. Na? Like this kind of topology. Instead of using hub and switches, we were connecting them through a single cable, If PC, so this is what basically a single collision domain. Why single collision domain? If two PCs try to send data, see if PCA is trying to send data, you know that data will be sent across all the devices in this room, in this particular. But what happens if multiple devices, like let's suppose at the same time, PCC also want to transmit the data when PC is transmitting. So he will send data. So if two devices are sending data at a same in a same collision domain, your data will be collided. You can see in a single cable, a single path is there. From that cable, we are sending data also, we are receiving data also. So data will be collided. So collision domain, we can easily think from here also. A domain where if multiple devices try to send data at the same time, the data will get collided. So it was at that time. But when we developed Hub, so you can see we were not using Hub at that time. When we developed Hub, Hub is a networking device that is having multiple ports. So you can see we are having three different ports. We are having three different ports providing connectivity to these computers. Actually, I draw the diagram of switch. Let me remove it. So you can see, even if we are having three different ports, but logically, this represents the same thing. This is representing the same thing. If PCA is sending the data, that data will be sent across to everyone. And what happens if multiple devices try to send data at the same time? PCB want to send data at the same time, because you were connecting to a single cable, collision is going to occur. So same thing is here also. Even if you are attaching a device that is known as hub, a single broadcast domain, and a single collision domain, even if you are having multiple port, but logically you are only having a single path to send and receive data for all the other ports. So this is what a single. So if someone asks you how many collision domains are there in your hub, a single. Even if multiple ports are there, you're single. So that's why I was just to make you confused. To make you confused, I was adding hubs in your network. Let's try last time. And now answer me, how many broadcast domain are there? A single broadcast domain, you can see. And how many collision domain? Just name, just give me the number. One, two, three, four. Four collision domains are you having here. Every port of hub, every port of your switch was having their own collision domain. So between switch and switch, you are providing connectivity in that same collision domain. No worries. What if I add a hub over? What if I add over? So you can, all the ports of hub belongs to a single collision domain. If you're connecting to different switches, but all the ports of your hub belongs to a single collision domain. So one collision domain, two, three, four, and five. And how many broadcast domain are there? A single broadcast domain. So by default, also your hub also is used to provide connectivity within a single broadcast domain. Little bit more clarity, sir. If still not, we'll try to do again, just for your reference. Okay. So that is about your collision domain and broadcast domain, guys. Okay. this point. So VLANs can be helped with the help of VLANs. You can divide your switch into multiple smaller.
Mister,
Yes, Boyo, please tell.
yeah, sorry, can you please share the syllabus also?
Syllabus also. Yes, I'll share the syllabus.
Okay.
You want me to share syllabus, or you want me to tell what things you're gonna learn, how you're gonna learn? That you ask, or just the syllabus part?
Yeah, everything. I just wanted to have it by my own so I can also go through it.
No, no worries, no worries. I'll share the syllabus to you on
Okay.
the WhatsApp group on which we are added. Okay, is that fine?
Okay, no problem. No, thank you.
Then, sir, that will be provided from us because that is a part of my job now. No worries. So basically, with the help of VLANs, because if you have covered your CCNA, by default, VLAN 1 is there. All the port of your switch belongs to VLAN 1. That's how you are making your switch understand. Hey, buddy, all the ports of you are connecting to a same network, to a same broadcast domain. How? With the help of VLANs. Later on, when you create multiple VLANs with me, you and me gonna create multiple smaller broadcast domain within your same switch. Okay. Each router interface represents a unique separate broadcast domain. Remember this point. I'm not talking about switch. I'm talking about router. Every port, every interface of your router belongs to a different broadcast domain. So if I go and get a router, you see, it's a different broadcast domain. If you want to connect your broadcast domain to a different network, you're gonna get a router. What is a broadcast domain? Basically a single network, where all the devices within the broadcast domain can send unicast data, multicast data, or they can also send broadcast. So I'm having a router through which I'm connecting 3 different networks. So basically every port of your router connects to a different broadcast domain. That is what the point is saying. This is a different broadcast domain, it's a different broadcast domain, and it's a different broadcast. Broadcast happening in a same network will remain in your network only. The router will never pass it to your next broadcast domain. It never passes by default, it never passes your broadcast traffic. Remember that. My main motive was to learn about layer 2 forwarding. Again, we are learning about switches, we are learning about broadcast domain, collision domain. That is cool. It is one thing you should be aware of. Now, this particular topic, how layer 2 forwarding is happening. So guys, before continuing, I want to ask you, what is switch? Can you please explain what all knowledge you are having about switch? What is switch, layer 2, MAC address table, whatever you know about? Boyo, can you please help me know? I hope I pronounced your name right. Is it?
Switch are network devices that also help to interconnect network devices.
Just give me a minute. I need to connect. Boyo, sorry for the disturbance. I need to connect my charger. Give me a minute. Yes. So what we can see, yeah, it's charging. So as you said, it's a networking device. True. It is used to create LAN. It's true. It's layer 2 device because it can receive data from layer 1. It's not like hub, it's receiving, but it can also read the additional information that is above the data. Layer 2 information basically. Okay, it is maintaining its MAC address table. Cool. Let's see. It is maintaining its MAC address table. You know that. What all things you can see in your MAC address table, Boyo? Can you please tell me? Which MAC address is connected to which port, it belongs to which VLAN, and whether that MAC address is dynamically learned or statically learned. Is it true? AA is connected to F0/1. It belongs to this particular port belongs to VLAN 1, and this MAC address is dynamically learn. So that kind of information you can see in your MAC address table. You should be clear about that. Okay, let's see. So see, layer 2 forwarding refers, we are talking about switch, refers to the process switches used to forward the frame. It's a process that that your switches uses to forward the frame. Although router also, basically your router can also understand your layer 2 information, but it is not checking your layer 2 information to forward data. Router is a layer 3 device, we all know, but it is not using layer 2 information to forward the data. It is actually checking layer 3 information that is present above the data to forward the packet to the actual distress. I'm not talking about different network. I'm talking about layer 2 forwarding. That means basically you are learning about how data is being forwarded within a single LAN, this particular area, how your switches will be forwarding. So we are having a few types of messages that your switch can understand. So few are unicast messages that your switch knows, that unicast MAC address, broadcast, and multicast. Let me tell you what is it. Okay, so here basically I have built a network. I have assigned IP address also. So let me go and first of all take the physical access of this device. And for reference, for the first time, I'm clearing the MAC address table. So do you know how to clear your MAC address table information? Or first of all, tell me how to check my MAC address table. Show MAC address table. In your privilege mode, if you type this command, you can see your MAC address table of that particular switch. It's switch 1, it's switch 2, and it's switch 3. Okay, we'll name that. You can see in my MAC address, it's having some information that I told you, VLAN, which MAC address, the type of it is learned, and the port. I'll simulate, I'll go here, and by typing a command, I can clear my MAC address table also. Manually, I can clear it, okay? Show MAC address table. So now it is empty. I'll go to my switch 2. And what I'll do, I'll enable config t, exit, show MAC address table. So I'll go ahead, clear MAC address table. I'll clear it also. Show MAC address table. So now it is also clear over here. And I'll go to the CLI for switch 3, enable show MAC address table. And I'll also clear my MAC address table that you are not going to do in the real production network. Here for your practical, we can clear your MAC address table, but you will not by randomly, you will never try to use this command in your production. Remember that thing. It will clear all the MAC address that it has learned. Okay. So we have done. So let me try. See here. Let me try to send data. Let me try to send some data. I'll send ping 10.10.0.0.4. Okay. Now press enter. Oh, not this one. I'll try to press enter. Okay. So when this computer A wants to send data to computer B, but the destination is within my network, source IP and destination IP belongs to the same network. This PC can see that. So he know that he can forward that particular data using layer 2 forwarding with the help of switch only. So above the data, you can see source IP of PCA, destination IP of PC4. So when the destination belongs to the same network, remember this point, when the destination belongs to the same network, the source MAC address will be of PCA, and you need to know the MAC address of destination, that is PC4. You need to know the MAC address. If you are not aware, you know a protocol is there. Guys, can you name that? Can you name that protocol that helps you find the MAC address of a known IP address? Can you name
Address
AR?
resolution
And
protocol.
right, address resolution protocol. So this time my computer didn't generate ARC because definitely he's aware what is the MAC address of this PC. That's why my computer has directly added that. But what if my computer was not aware of the MAC address of destination? Then guys, he must have so kept this message in hold and generated a ARP request that we're gonna cover in the next session, not today. A ARP is there that is that is used to find the MAC address of a known IP address. But this time a computer was aware, so it didn't generate the ARP. Okay, no worries. It's not compulsory that every time it will generate. It will only generate ARP if he does not know the MAC address of destination. Only keep that in mind. Right now it was aware. So it will forward the data because all the information was there. It has forwarded the data from its port. Now this switch, this particular switch, this is your switch one. Switch one received that data from F0/1. Do you know what is the first thing when your switch receives the data from any of its port? Fab. Everyone, guys, everyone. Today is the first day, so sorry for because the name is not. Yeah.
I think first we will look for the
Destination
timetable.
method.
No. The first thing, as soon as the switch receives the data, it do learning. It do what? It does.
It learns the MAC address and put in the port.
Yeah, it will learn the MAC address of sender. The first thing. Remember these points, these beautiful 3 points. How switch both. First thing is learning. Whenever your switch receives data from any of its port, and whenever the first thing is learning, and what is gonna learn? The source MAC address. Not gonna learn the destination. It's gonna learn, oh, from my F0/1. That means PCAA is connected. Okay. If I go and show you the MAC address table of this particular switch by typing show MAC address table, okay, so definitely, so see what happened. We know that, hey, from F0/1, this particular PCAA is connected. This particular MAC address is of my PCA. Okay. Then the second step is what? Then the second step is forwarding. After learning, the second step my switch do is forwarding the data from the port by looking at the destination MAC address above the data. So now your switch will check the MAC address that is present above the data. Let me go. So you can see the destination MAC address was 1703. So your switch will now check the destination MAC address in the MAC address table. Let's see whether we are having. So can you see in our MAC address table? Can you see the destination MAC address information? 1730. Let me show you again. This is the MAC address of destination 1703. So we can see my switch was not aware of destination. My switch is not aware of the destination. So if the switch is not aware of the destination MAC address, so what does it do, guys? It start flooding. It start doing what? Flooding. If the switch is not aware of destination, where the destination is connected, it's not gonna drop the data, but it's gonna broadcast it out. And this broadcasting is done by switch. This broadcasting was not intentionally sent by from your PCA. Your switch is doing broadcasting because he is not aware of the destination. You can see here. See, it broadcasts the same data out from F0/2 and F0/3, the ports that are being used here. Let's go back a little bit back. You can see here the switch, because the destination was not aware, your switch is doing flooding. So this is what the point I was telling you. If your switch, if you are sending a unicast traffic, but the destination MAC address is unknown, your switch flood out the same data from all the port except the port the source is connected to. So basically he's doing what? Flooding. And when he'll do flooding, bro, guys, when a unicast traffic is received, but the switch is not aware of the destination MAC address where it is connected to. Okay, so at that time he will flood. And you can see the flooding is received from here also. When these switches receive same message, they will also perform learning. Learn the MAC address of sender from F0/3. Learn the MAC address of sender from F0/3. Here also same port. And then they will look for the destination MAC address. If they are also not aware, they will also do the broadcasting. So you can see they are doing flooding basically because they are not aware where the destination is connected to. Now you can see the same ping somehow, because of the broadcast done by switch, was received by the destination. If the destination is present, now he will generate a ping reply. So ping is a two-way communication. You will send a ping request and a ping reply should be received. So when this is generating a ping reply, source IP of M, destination IP of PCA, source MAC address of M, destination MAC address of PCA. Why destination MAC address of PCA? Because sender and destination both belongs to the same network. Remember this point. When sender and destination both belongs to the same network, the destination MAC address should be the destination only. But if the destination belongs to a different network, but what if a destination belongs to a different network? Then the destination MAC address will be of your default gateway, not the destination. We'll be talking about that when we'll be talking about a different layer forwarding, that is layer 3. You see, when this PC sends a reply, your switch receives that data. If I show you show MAC address table, this is the command. Guys, I'm going to ask you today, my journey is not about how much theory you are aware of, that you learning. My journey with me, I want you to be good with commands also. The show MAC address table, you can see here, as soon as your switch receives the data from F0/2, it learns the MAC address. Then it checks the destination MAC address. He will check the destination is connected to F0/3. So if he's aware of destination, he receives a unicast message, and he also is aware where the destination is connected to. So this time he will not flood the data. This time he will send the data out from the port the destination is connected to. Now that same data is received from your switch one. Switch one will also do the same thing. It will learn the MAC address of sender. So this time the sender is PC4 and the MAC address was 1703 that was received from F0/2. Now, after learning, he will check the destination MAC address. He will check, hey, the destination MAC address is this, and this entry is present in my MAC address table. So instead of doing flooding, it will forward it out from the port. The destination is connected. So that's how things are forwarding. This is what layer 2 forwarding is. So this is what I want to teach you. What is unique when you send a unicast traffic and your switch is also aware of the destination MAC address where the destination exists is connected in the MAC address table, it will forward the data out from the specific port only. It will not forward the data. But if your switch receives a unicast traffic and the destination MAC address is not aware by him, so at that time he will do flooding. He will flood out all the data from all the port except the source port. What if Sumit, this PCA sends a broadcast traffic? This time he was sending unicast traffic. What if sometimes he send a broadcast traffic? So at that time also, so if PC sends a broadcast traffic, that means the destination MAC address should be 12 times F. If any device sends broadcast traffic, that means the destination MAC address is 12 times F. Your switch will do the same thing. Flood out the data from all the port except the source port. Same thing, but this time you made him do flooding. You ask him to send broadcast data to everyone. Your switch didn't automatically do flooding because this time PCA wants to send a broadcast traffic. That's why switch is flooding out the data from all the. Last but not the least, guys, we have a concept of multicasting. Can anyone tell you what is multicasting? When you want to send data to multiple devices within your same network. When you want to send data to multiple devices within your same network, not all, but multiple devices. So you need to do multicasting. So guys, by default, see, we need to set up multicasting on a switch. Otherwise, if you haven't set up multicasting on a switch, if a switch receives a traffic for multicast address, if it receives a traffic for multicast address, by default, its action is to flood the data. Until and unless you have set up like IGMP snooping or GMP configuration, CGMP configuration on your switch to support multicasting. So by default for multicasting also, it is doing what? Flooding, broadcasting basically. Okay, keep that in mind. So that's how your switch is doing, sending forward. So basically, if someone asks you how switch works, it performs learning, it do forwarding, and the third step your switch is taking care of, that is loop avoidance by using spanning tree protocol. If I ask you what is the timer for MAC address learn, you should be clear with that also, guys. Boyo, Babel, everyone, sir, everyone. Bala Murlai sir, Daniel, Bentelina.
Yeah, sure.
Yeah.
So it's 300 seconds. Your switch stores your MAC address that he has dynamically learned only for 300 seconds. Let me go here and show you the MAC address table. Show MAC address table. So he has all the MAC address he has dynamically learned. Let me increase my timing, guys. Let me increase my timing. I have increased my timer 10 to 5 minutes ahead. Okay. So definitely you can see the MAC address have been now reduced. Because in the background, my switch is still sending some data. So it is learning those MAC address. But these MAC address will only stay for 300 seconds. If within 300 seconds they receive another frame from the same source MAC address, then they will update their timer. Guys, that this 300 seconds is your aging time. It's known as aging time. When it will remove this particular, you can increase and decrease this aging time according to your requirement. We learned that today also. Okay, we learned in today's session only. Done. So before continuing, let's talk about your MAC addresses. Let's talk about your MAC addresses. I hope you know about your MAC address, in which format your MAC address are represented. So basically your MAC address are represented in hexadecimal format. In hexadecimal format. In hexadecimal format, you're having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But after 9, we are having more value, not 10, 11. A, B, C, D, E till F. So in hexadecimal format, you're having these options and your MAC address will be in between only these characters only. Not more than that, not less than that. But between these, because your MAC address is represented in your hexadecimal format. So to represent a single MAC address, it took 48 bits in background. How many bits it will take? 48 bits. But if I convert this bit into byte, so basically you can say 6 byte. Your MAC address, you can say it's you can also say it's 48 bit and you can also say it's 6 byte. Both of them are same. But here we are using a different unit and here we are using a different unit. Okay, so let me write down my MAC address, a random MAC address for your reference. AA1B 7981 F1 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can see this is a valid MAC address. How can I know? Because I know the foundation. Guys, your MAC address contains 12 hexadecimal characters. If I talk about human readable format, how many MAC address character, how many hexadecimal character does it require? 12. This is first, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, and 12. So 12 hexadecimal characters are required to represent a single MAC address. To represent a single MAC. But in background, it is taking 48 bits, or you can say 6 bytes. Okay, so that's good to go. Now, guys, your MAC address contains two things. Your MAC address contains two things. One is OUI. Your MAC address contains two things. Half part of your MAC address is for your OUI, organization unique identifier. Every organization has a code. Every organization has a code that is fixed for, that remains fixed for every NIC card. Okay. And it has a specific part. The next half part is the NIC. Basically, your organization is maintaining it same. Organization is maintaining it so that it will be unique. Unique path. So basically, MAC address contains two things. One is OUI and other is NIC specific. OUI stands for Organization Unique Identifier. Every organization, whether it's Cisco, whether it's Intel, whether it's Dell, every organization has this has its own unique OUI. Okay, a single company can have multiple OUI also that they have purchased for themselves. Okay, it's not that they will only have a single OUI. So the first half. See, the first half of your MAC address, let's suppose the first 6 characters represents your OUI. By looking at it, You can identify which manufacturer created your NIC card. And the next half part, that means next 6 bit, are uniquely made by that organization. When these are combined together, so in the world, the same MAC address cannot be used by any other company, because OUI should be also there, and this OUI is only like given to a specific company, not to all companies, and that company is taking care that the next 24 bits or maybe 6 characters are unique in within their company. So when these are combined, they will make a solid unique MAC address that is never copied or never used by any other vendor. So your MAC address contains two things. One is OUI, other is next specific. It is uniquely assigned by your vendor, whosoever build it. Okay. So the first, you can say first 24 bits is your OUI and the next 24 bits is your next specific. Or you can say the first 6 character are your OUI and the next 6 character are uniquely identified within your organization. Your switches are maintaining your MAC address table. Your MAC address table is also known as CAM table. Both are same. The full form is content address memory table. Your MAC, whatever MAC address they are learning, it is stored in your MAC address table. Your switch only learns MAC address table as soon as your switch only learns MAC address in the MAC address table as soon as they are receiving data. And they are only learning sender MAC address, not destination MAC address. This is the behavior. Okay. If you want to check your MAC address table, you can type show MAC address table. So in that table, you can see a lot of MAC addresses. Okay. Here also, here also. Let me show you and let me open a lab for you. So guys, here in your CCNP, you're not gonna learn in your, we are not gonna do practicals in your packet tracer. We are gonna use another software that is your EVNG or maybe PNet Lab, any network simulator. I'll open my virtual machine. I'll show you this in the real device. Okay. I'm not using EVNG, I'm using another same concept, but it's PNet. Okay, it's a different software built by a different organization. So root 192.168.110.11. Okay, IP is this assigned to me. 192.161. So here I'll type admin pnet capital U4. SH. Let me show you. Let me go over here. So we have built a topology over here. And these switches are on. Let me close them because I might have done some configuration over here that can create some conflict. Let me close it and build my own lab. I'll close this lab. I'll go and create.
Smith, can you hear me?
Yeah, I can hear you, sir. Tell me.
This EVNG, this we also can download and practice, right?
Yeah, you can also download and you should also, it's not like you can download, you should also download because you have to practice over there, sir.
Okay,
For that,
this is we have two versions, right? Like a free one and a paid one.
like community and one is professional. This
Yeah, that professional is some kind of paid, I think, right?
paid. But you can, for your CCNP part, CCI part, you can
Mm.
freely use the community version. You can work on that.
But
Yeah.
okay, so any hardware requirement, like
Yeah.
is it
Really,
okay with the laptop or we need to
it's
go only with desktop something like that?
you just need to have a decent laptop. Decent means at least you should have 16 GB of RAM. Guys,
Okay.
I have also installed EVNG in my previous laptop that was 8 GB, but it was lagging too much. I was building lab, I was learning configuration, but it was
Mm.
taking too much of time because it was lagging because the
Okay,
software
okay,
lots of resources. So now I have upgraded my laptop, 16 GB of RAM. My CPU is i5 11 generation. So it's a decent,
okay.
not a good one, but decent one
Oh, okay.
where I can like add 10 to 8 devices, not more than that. If I add 15 devices, 20 devices, my computer,
Okay.
because it will not have enough resources to handle those kind of things. Are you getting what I'm trying to say?
Yeah, got it.
So at least 16 GB of RAM. If you're having a laptop which is having more RAM, it's cool, no problem. Like 32 GB, 24 GB, it's up to you. But 16 GB of
Okay.
RAM is required decently, and you should have a processor that should have more 8 core or at least 4 core. 8, not
Okay.
logical one. I'm talking about core. 4
Physical course. Okay.
processor. So then it
Okay.
can handle like instruction more properly. You can see right now my laptop is doing lots of things in background. You can see it through the graphical thing. No worries, no worries.
Yeah.
Uh,
Got it. Thank you.
if you are having any difficulty while like accessing your like installing EVNG, or all, you can directly contact me and I'll help you. I'll
You have installed this EVNG on the VM only, right?
Yeah, VMware also.
Okay. Yeah.
Or what else I can do? I'll in tomorrow's session I'll show you how to properly set up your lab on your laptop for EVNG, not for PNet, but lab. For today's session, just be with me, because my motive is not to use PNet and EVNG. My motive is used to teach configuration. So I'm comfortable with both of them. Okay. According to my laptop, I know PNet will be a little bit lesser, uh, like little bit lightweight as compared to your EVNG, and a little bit more flexible. Okay, but it has its own drawback. So let's go and just build my network. I'll go and click node. I'll go VPC. Here your computers are represented as your VPC. You have to choose desktop images. Let's go and add 4 nodes of the same device. So Sumit, you have got all of these devices are right now turned off. Okay, shut down. By color, you can see them. Let's go and add 2 switches. I'll go and click on node. Here on the switches, I have installed Cisco IOL layer 2. Then here I want 2 switches. These are switches, not routers. So I'll start with SW. And instead of router image, I'll choose switch image. I'll go here and type switch. This is a switch image. Select one. A little bit of, it's not that difficult, but it's a little bit complicated as compared to your packet tracing. Done. Now let's provide connectivity from switch to PC E0/0 to switch Ethernet 0. Okay, no worries. Then from my computer's E0, Ethernet 0 to switch E0/1. Then from between switch to switch, I need to provide connectivity E0/0 to E0/2. You can see the name also. This is how you are providing connectivity. So you provide cables before turning on your devices. Okay, I have added these devices. Let me on the right hand side. Let me open my this so that you can monitor my resource. Yeah, can you hear me, guys? Yeah. So basically, I have connected these devices, and now I'll go and quickly like play the play button over there. So these devices are getting turned on. Okay, basically switched on. Now you can see blue. By looking at the color, you can identify that these devices are now on. Okay. So then, so second thing, somewhere you need to decide logical addressing. Do it here also. Let's suppose the network we are running 192.168.0.0/24. We are running here. Okay. I have to go double click on the devices. You will get a prompt like this. Click open SSH. So yeah. So you will get the terminal here in this particular thing. So here, how to assign IP address in this, it's a little bit different, but no worries. For this purpose, we'll learn. Just type IP, and then the IP address that you want to mention, 192.168.0.1, subnet mask 255.255.250. That's all. IP and the IP address that you want to assign and the subnet mask. I didn't mention any default gateway. We'll learn how to assign default gateway by commands later on. Okay, so I have assigned .1 IP to this. I'll go here on this particular PC. Not enable IP. It's not your switch mode. Okay, it's not your Cisco CLI enable privilege. It's a different terminal of your computer. Okay, IP 192.168.0.2, 255.255.255.0. That's all.
So, Mister, I'm sorry. So here you don't need to add interface.
No. You don't need to You do not need to mention interface. It's
Okay.
here on this virtual PC, on the computers that you're adding over here. Okay, for them. Is it
Okay.
fine?
Yeah.
No. Then IP, then 192.168.0.3, then subnet mask 255.255.255.0. That's all. It's checking duplicate IP address. It's checking. Okay. Last computer over here is, let's go here. IP 192.168.0.4, subnet mask 255.255.255.0. So I have successfully assigned IP address. If you want to have the terminal access of your switch, just double click over here, and then you can access the CLI of your switch also. But select this terminal, press enter multiple times, you will get this prompt. Okay. If somehow it's not opening, let me know. It might be some not proper. You haven't, because these switches are not predefined, pre-built over here. I have installed these switches images over here. So sometimes you might have downloaded a corrupted image, or maybe you have not properly installed these images on your PNet or maybe EVNG. So you have to be clear with that. Let me show you the MAC address table. I'll type enable, I'll type show MAC address table. And when I did that, you can see all the MAC address that my switch has learned. So these are your dynamically learned MAC addresses. And can you see the total MAC address he has learned? That is 9. So it is also maintaining here that how many MAC address he has learned on that particular. And if we have multiple more commands, let me take you to that. So guys, see here on your switches. So basically you will get your MAC address over here. Guys, few MAC addresses are also there that is present in your MAC address table that you cannot see over here, but those are there, which are used by your computer, which are used by your switch only. For example, VTP, DTP, STP, VST, when he is sending some messages, they are having their own MAC address for CDP, for VDP, for DTP, for PVST. So those MAC address you can also see in your MAC address table. And if these are written and the ports are CPU, that means it's generated by your switch only. But those MAC address he has learned, you can see the port number F0/123, whatever you feel like. Na? So guys, you can add static MAC, you can statically enter MAC address. Guys, you can statically add MAC addresses. Okay. Then here you have a topic like MAC address learning. So guys, by default, whenever switch receives the data, he performs learning. He performs learning. That is automatically done. He add the MAC address of senders in the MAC address table. Guys, if you want, you can disable that also. That, hey, do not learn the MAC address. Whenever you are receiving data, do not learn the MAC address. You can do like that also. So by default, dynamically MAC address are learned is enabled. That's why it is learning automatically. But you can disable it also, or you can control. So you can see, let me show you a command. So can you see here? The command is what? Show MAC address learning. So if you type this command in your privilege mode, it will let you know for which VLAN he is learning. So by default, VLAN 1 is there. So it will show you. Let me go to my switch. The command was show MAC address learning. So on this particular switch, the learning command is not available, but still in a different vendor switch, it might be available. So you can check which MAC address he is learning. So let me check here one more time. Switch MAC address learning. The command is correct, 100% right. So here you can see for which MAC address he is learning. You can avoid that also. You can stop your switch to learn MAC address for a specific VLAN. So for that, you can type a command no MAC address table learning VLAN, and for which VLAN you want to stop, you can mention that. Let me check if learning command is not available. So definitely this command will be also not available on the model of switch I'm using over here. It's not that every switch will be not having this command. Let's try. If I go on my global mode, if I type no MAC address, let me type question mark over here. Okay, so here learning part is not available for this particular switch. Learning command is not available, so I cannot set and remove learning part. No worries. My second step over here is, but at least you should be able to understand the command, that you can control that thing also. If that command is available, you can stop learning. You can make your switch stop learning the MAC addresses. No worries. So, and by typing do show MAC address table learning, you can see for which MAC address, for which VLANs he's learning a table. No worries. The next thing is, Somit, you mentioned us that whenever switch receives a data, it do learning part automatically, which you are saying that you can control. Okay. Now you also mentioned that the timer was 300 seconds. If 300 seconds has passed, then the MAC address will be removed that he has learned. So you can stop, you can change that MAC address timing, aging time. You can set to 10 minutes, 15 minutes. And if you set aging time to 0, if you set the aging time to 0, see, if you set the aging time to 0, you will disable aging. That means your MAC address will never delete. It will always be there until and unless you cleared your MAC address table. It will not dynamically be removed. So if you want to change your aging timer, let's go. I'm on my switch. You can see on the left hand side. I'm on my privilege mode. I'll simply type MAC address table aging and press question mark. So you same input you can see here. So by if you mention 0 here, so your MAC address will never be removed. Whatever they have dynamically learned, the timer will be turned off. But you can but you can control your timer also. So the minimum is 10 seconds and the maximum is, you can see, 1 lakh seconds. This is how you can change. Remember, if someone asks you, hey, I want to stop the aging timer, that it should not dynamically remove. So it's simple, sir. Just set your aging timer to 0. Then what happens? Your switch will never delete your MAC address, whatever he has learned. Then you have to manually delete it. Okay. You can set the aging timer per VLAN basis also. Aging timer can be set globally or per VLAN by using VLAN keyword. So that can also happen. Okay. No worries. I hope you are able to learn what things are happening. Guys, you can also the next topic over here is statically mentioning the MAC address. Guys, your switches dynamically are performing learning path. But you can statically mention, hey, switch 5 from your E0/0 PCBBBBB is attached. You can make your switch have a static MAC address. So let me go and do that. Let me go. So see, MAC address table, then static, then after that you have to mention the MAC address. Let's suppose AAAA dot A1. I'm writing a random MAC address. Okay, it's not compulsory. Just for your reference. And then we have to mention VLAN. For which VLAN we mention VLAN. Command is incomplete. Why? And interface I have to mention. First of all, VLAN 1, and then interface. Interface is E0/1. This particular MAC address is connected to E0/1. I'm manually telling you. Now this command is running. If I go exit and type show MAC address table, guys, you can see one MAC address is statically entered. Okay. So if 300 seconds have been gone, this MAC address will never be removed because it is statically mentioned. Only the timer is for the 300 seconds timer are for the MAC address that are dynamically learned, not statically learned. Okay, remember that point. So you can make your switch learn MAC address statically, and you can also control it. See here, by the next command, what I'm doing, I'm telling my switch, hey switch, MAC address table static. I'm mentioning the MAC address VLAN 1 drop. So what happens? Basically, if my switch receives a traffic for this particular VLAN, the sender is this particular VLAN, it will eventually drop it also. So basically by using this command, you are explicitly telling your switch to to drop a traffic from source or destination for a particular MAC address. It will check whether it is source or destination. It will simply drop that MAC address. Let's see whether on my switch we are having this command or not. Go on your global mode, type MAC address, then your static, whatever, A1, B1 dot. I'm just writing the MAC address, okay, for your reference. Then 1234 dot 1234. That's okay. VLAN 1. Let's suppose press question mark. So see here, we are not getting any drop option over here, but we have a drop option also in a different switch, in a different model switch, from where you can let your switch know, hey buddy, if you receive that traffic from this particular MAC address or maybe a destination as this, then simply drop it. So you can control that thing also, guys. Basically, these kind of commands you can get in your Nexus switches. a higher level of switch where you have more control. Okay. Then clear MAC address I have mentioned, guys. How to dynamically how to clear your MAC address table by using a simple command, that is how it is. Yeah, clear MAC address table. So you can remove dynamically MAC address can be removed. So clear MAC address table dynamic, it will do what? It will remove all the MAC address that are dynamically learned. As simple as that. But if I type clear MAC address table, then it will remove dynamic and static both. Let's go and check. So before continuing, if I type show MAC address table, guys, you can see we have static and dynamic. If I type clear MAC address table and type dynamic after it, it will only remove the MAC address that are dynamically entered. Let me show you show MAC address table. Now you can see all the MAC address that were dynamically entered are removed. But if you type clear MAC address table, okay, that is the idea. So MAC address table. You can see all the dynamic MAC address are being removed. I was trying to run this command without dynamic. Here it's showing some error, but no worries. Which model switch I'm using over here? Node, IOL, okay. And I have another model. I have installed another model of switch. It is showing invalid. So here in EVNG, we are having multiple like things that you can control, but no worries for right now. First thing that we need to start building a network here in the EVNG. Do not go directly to the higher level of advanced concept. Otherwise, you will get confused how to add switches, how to add router, why it is not working, why it's not capturing. Even if you can capture traffic between here. So let me show you how to capture traffic between here. I'll select HTML console. It worked for my PNet. It's not same for your EVNG, but still you can capture that. Right click over here, click on the device. You have a capture option over here, capture on Ethernet E0/0. So we are having a software that is known as Wireshark. So Wireshark is also here in your EVNG and PNet lab, where you can start capturing real traffic within your lab. So you can see, let me go and try to ping from PC1, PC4. Okay, let me try to go on PC4. Open. It's not opening because why it's not opening because it's already open over here. If I try to ping 10.192.168.0.1, now you can start seeing that hey, the ICMP packet that I'm sending, it can my PC1 can sense over his link. Who is sending, to whom it's sending, ICMP packet, echo request, echo reply, whatever it is, you can see from here with the help of capturing. So right now, I'm not going in that depth about your what all functionality you can get over here in this PNet and EVNG. But my major concern is layer 2 forwarding, how data is being transmitting within your LAN. Collision domain, broadcast domain, your MAC address information, dynamically learn, statically learn, broadcast domain. Okay. And we are having another command. If someone asks you how many MAC address can be learned, so basically by typing show MAC address table count, you can get information. You can get a statistic, how many marketers dynamically learn, how many marketers statically learn, and how many total space. If I go here on my switch, let's go and type this command, show MAC address table count. So count is available. So can you see, guys, can you see the difference here in this PDF and here in this real in the switch that I've installed? So total MAC address that you can learn over here is this much, and and it is not fixed for every switch. It's different for every different model. Every different model has their own specific flash memory, RAM specification, and other things. So according to that specification, it can store MAC addresses and other activities. Is it fine? Any doubt till here, guys? Any doubt till here? Any one of you? So whatever we have learned these commands till today.
What is that total MAC address space available? 4061.
4061. Why you are saying?
Yeah.
You are saying.
Yeah,
So
yeah. What is that?
basically, how many MAC address you can store? How many MAC address can be stored in a MAC address table? So every table has a limit now, according to you. So this limit you can see by typing this command, show MAC address table count. So here you can get a statistic, how many MAC addresses are dynamically learned, how many MAC addresses are statically learned, and total number of MAC addresses that you can add here in your MAC address table that your switch can have in your MAC address table. So here in this PDF, it is showing 4061. It's for your reference, but here and when we implement on the real switch in our EVNG, it's showing a different value. So this particular switch that I've installed in my PNet lab can store 221557608 number of MAC addresses in its MAC address table. Is it clear, sir? The total number of MAC address it can save? So you can get idea of that. Every switch can have their own number of
Yeah,
MAC.
yeah.
Okay, so
Yeah,
that.
got it.
So guys, today we learn about collision domain, broadcast domain. We learn about when we were having a network where we are having single collision domain, we were using CSMA/CD to avoid collision. You know what is half duplex, you know what is full duplex. You know about MAC address table, CAM table, both are same. You know about OUI. Basically, why OUI? Because we are learning about MAC addresses, na? Organization unique identifier. First 24-bit, or you can say first half your MAC address. You know, your MAC address contains 12 hexadecimal character. First half 6, another 6 half. So first half, basically OUI, and the next half is your unique identifier. You know what is flooding? When does your switch start flooding? What is aging time? What is default aging time? So that's all. So guys, this PDF will be also uploaded. So we have some your MCQ question. What I want go through today, I'll not like. I want you to go and read out the PDF that we'll be sharing. So every day, whatever we'll be learning, we'll be recording your session. We'll be sending your PDFs and the video on my drive. Okay, I'll upload all the video lecture and the PDFs on the drive one by one, as soon as we are covering the topics. Okay, from where from my drive, you can go and check and read out your topics. So let's just do some question before ending the session, guys. Which OSI layer is responsible for logical addressing and routing, guys? Basic question. Which logical layer? Network.
Network.
Network layer, 100% right. In TCP IP model, which single layer correspond to OSI layer 5, 6, and 7? In OSI, what?
Application.
Application layer. The answer is C. What is the data unit called at transport layer after encapsulation? That is, they are asking about your PD. Basically, that is
Segment.
Segment.
segment. What is added to the data when it becomes packet? Guys, what is added to the data when it becomes a packet?
Layer 4 header plus layer 3 header.
Layer 4 header plus layer 3 header. Definitely above the data, you need to have layer 4 header at transport layer. Then it goes to the network layer. You need to add layer 3 header also. Layer 4 plus layer 3, that means packet. 100% right, sir. Which term describe communication that happens directly between two applications on end-to-end? Interesting. Which term describe communication that happens directly between two applications? Is it process to process between two applications? That is process to process. From your application to another application, you're communicating process to process. But when your transport layer is communicating to destination transport layer, it is said host to host communication. Okay, that is the part. And the next question we are having, all device connected to the same Ethernet hub belongs to separate collision domain, the same collision domain, separate broadcast domain only, or none of the above. All devices connected to the same hub belongs to a
The same
Same
collision.
collision domain.
Single collision domain.
Same collision, guys. Right answer. Why can a device connect to a switch operate in full duplex? Why can devices connect to a switch operates in full duplex mode? Because every port of switch
Every
has,
port is a single collision domain, right?
that's why,
one collision domain. Yes.
so that's why you can make that particular thing have full duplex mode. Which device does not forward layer 2 broadcast frame between its interface by default?
Router,
Router is a device that will never forward the broadcast happening from one interface out from the other interface. The answer is option C. Then switch receives a frame destined for MAC address, not in its MAC address table. Let's suppose you are a switch, it receives a frame, but you
it
don't know
floods the frame,
it floods the frame out from all the port except the source
received
port.
it.
Make it complete then. Okay.
Yeah.
Then what is the destination MAC address of broadcast frame? That is 12
What is the
times
destination MAC address?
of a
Okay,
broadcast.
all F. All
All,
F.
all. Okay. So they have written a MAC address in front of you. They want you to identify which portion represents the OUI. So the first 6 characters,
20.
yeah,
Yes.
that is option B. Option B is the so first half, 12 characters are there. First half is OUI, and the next half, next 6 characters are your uniquely built by your organization only. So option B. Okay. What is the default MAC address aging time on your Cisco switches? That is
300
300 seconds. Guys, which command disable MAC address table aging time entirely? How can you disable your
0.
so
Aging time
MAC
0.
address, yeah, aging time. So right now
Yeah.
you just learned it. But what if this question was asked you like after 10 days? Then definitely you might have been
Forgot.
sometime, yeah, forgot. So it's just the way revise also, guys. Revise and
Yeah.
revision is the key to your success, guys. Not only learning but also revision. So yeah. And no worries, no worries. Aging, which command configure a static MAC address that silently drops from a specific? I told you we are having a command MAC address table static, then MAC address VLAN, which VLAN and drop. This is the command, but this command was not working on the switch that I have installed. Okay. And which command clears only the dynamic entries from the MAC address table? It's very simple. Clear MAC address table.
Dynamic.
Dynamic. So that is how you can remove the MAC address which are dynamically. So these few questions are there. I have few short questions over you that you can go and research for yourself. If you still have any doubt, you can ping us. I'll reply you. I'll be most happy to assist you. So for today, that's all, guys. We'll meet in the next session tomorrow at the same time. And thank you so much. Have a great day, guys. Thank you.
Yeah. Thank you, Smith.
No worries, sir. We'll meet you tomorrow and we'll learn more things.
Thank you.
Welcome, sir.